This is another experiment, bars of varying cross section subjected to loading, and we will solve this problem using Ansys APDL software. And this is the figure, and it consists of two various members, aluminum and steel, and one load is acting at the middle of the cross section. The dimensions are 300 mm and 400 mm is given. Okay, these two members are different materials and different Young's modulus. Area of the aluminum 2400. Now in order to solve this, go to preferences, structural, elastic, element type, add the element. Here I am adding the link element, 3D finite. Click apply, and here we need to consider two elements. Why? Because we are having two cross sections, therefore consider two elements for solving the problem. Click OK. Then again add another link element. Click OK. Then close. Here we are having two link elements. Then go to material properties, material models, structural, linear, elastic, isotropic. Then give the values. Here the aluminum is having 2400 mm square area, and Young's modulus 70 into 10 cube, 70 E3, and Poisson's ratio 0.3. And again here go to materials and select new model, and new model material is having 200 E3 steel and Poisson's ratio 0.3. Here two material models are defined here. Then we need to go to sections, link, add. Here link, take down as link 1. Link 1 as I am taking as aluminum, and here give the section name as aluminum. And what is the area? The area present in the problem is 2400 mm square. Give the area of the link as 2400. Click apply. Then again select 2. Then give the name as steel, and the area of the steel is 600 mm square. Give the area 600. Click apply and OK. And click OK. Now here the material properties are defined and the area of the cross sections are defined. Go to modeling, create nodes in active CS. Just we can create 3 nodes. One node is having 0, 0, 0. Node 2, it is situated at distance of 300 mm. 0, 0. Apply. Node 3, 700 mm. Apply. Click OK. Now here 3 nodes are defined. Now go to the lines, join 1 and 2 and 2 and 3 and click OK. After joining through lines, go to meshing, mesh attributes, picked lines, pick first line and give the material here. You can change here, that is first line is link 1, it is aluminum. Then select link 2 for the next material, that is steel. Here we need to assign the materials. Click OK. Now for the link 1 aluminum is assigned, for the link 2 steel is assigned. Then go to mesh, size controls, manual size, picked lines. We need to divide these lines into some divisions. Here I am giving 5 divisions. So the first line is divided into 5 divisions, and the second line also you can select. Here I am dividing into 10 divisions. Okay. Now before doing the meshing operations, we need to divide these elements into various discretized elements. Okay. Now here the first line is divided into 5 and the second line is divided into 10 numbers. Now go to mesh, lines, pick these lines, line 1 and line 2, and you can click OK. Then the meshing operation is finished. Okay. Now in order to give the loading conditions, plot, go to plot controls and go to the nodes. Then the nodes will be defined. Then go to modeling, go to loads. We need to give the loads. Therefore, go to loads and displacement I'm giving. Okay. Displacement on first node and third node. Okay, it is constrained all degree of freedom. Click OK. Then the displacement is constrained. Now the force should be acting at the node 2. Force on nodes. Reset. Okay, select the nodes carefully. Then select that node, click apply, and its fx value it is 200 E3. 200 into 10 cube. 200 E3. I'm giving that value here. You can give directly 200 E3 and click OK. Now this problem is ready to solve. Plot key points and plot. If you plot lines, then the lines will be displayed with the boundary conditions, and also the load is acting at the mid of the bars. Now go to solution, solve current LS. Now the solution is done. Now in order to view the results, general post processor, contour plot, nodal solution, displacement vector sum, then the displacements are displayed. In order to view it carefully, style, size and shape. Okay, in order to observe the cross section, click OK. Okay, style, size and shape. If you click on, it is in the off condition, change it to on condition, then you can observe the cross sections in an isometric view position like this. Okay, aluminum and steel. And here you can observe the deformations also, where the load is acting at that condition. Okay, the bar is severely stressed here. You can observe with red color, and you can note down that value 0.232. It is the value of the deformation takes place at the mid of the bar. You can also see the animated video. Okay, this is the cross section. Okay, now if you wanted to see the stresses and forces induced in each member, then you need to define the table. The dialog box, type set comma L step. Then after typing this, we can define the table. Go to the element table, add, and here you can give stress value, stress by sequence number. Select here LS comma 1, apply. Then select forces, type forces, select by sequence number SMISC 1. Click apply and click OK. Now here the unnecessary thing you can delete. Then here we are having two things, one is stress and another one is forces. In order to view those parameters, go to plot results, line element results. You can click here stress deformed shape, then you can observe the stresses induced in the two cross sections here, how the stress is distributed across these two bars of varying cross section. And if you wanted to view the forces distributed in these members, you can select here line element results, click forces here, change stress to forces, then you can observe the forces distributed in these two members. If you wanted to see the elemental solution, then also we can see the elemental solution. Elemental solution, stresses, 1 measure stress. You can observe for element 1 and element 2, element 3, element 4 and so on. For the discretized elements, we can observe how the stresses are distributed in each and every element. And if you wanted to see the reaction solution, go to reactions, all items, click OK. Then you will observe the reactions at node 1 and node 7. Okay, these nodes are generally fixed nodes at the starting node and the ending node. You can observe Fx, Fy and the resultant forces. Okay, like this you can observe the deformations, stresses, forces, elemental solution, reaction forces induced in a bar of varying cross section subjected to loading. You can also animate this video and see the mode shape or the deformed shape, how it gets deformed against the applied loading conditions. You can apply this knowledge to the real-time problems of various cross sections of the bars by changing the parameters of areas and also the dimensions, and you can see the how the deformations takes place here, the initial deformation and the final deformation, and you can estimate the stress values and where the failure takes place, and based upon that you can estimate the factor of safety of the entire cross section. Thank you for watching this video.